Firstly, thank you very much, Brett, for giving me opportunity to present you on my podcast.
That's excellent. I appreciate the opportunity.
So I've gone through your profile. I can see you're doing great work. So I thought to tell about your work to my audience.
Wonderful. Wonderful. Yeah. So I
So,
guess, sorry, go ahead.
you go ahead. Yeah, you're saying
Oh, okay.
something.
Well, thank you for having me, Sai. My name is Brett Lloyd. I'm based in Ontario, Canada, and I'm the solo founder of Corp. That stands for Structured Language Intelligence Corporation. A little bit about my background is I've been a master electrician for more than a decade. I've run my own electrical contracting business for the last 9 years. In that time, I've worked across residential, commercial, building automation, installing hundreds of different electrical devices, from control systems to equipment, smallest occupancy sensors, to full panel work. Specifically, over the last year, I've built a platform called IoT Studio. And it's a visual way for anyone to design and deploy their own smart devices without writing code. So, what I want people to take away from this conversation isn't really just the product, though we'll talk about that. It's the path. Because I think there's a lot of people out there who look at a problem in their industry and they think about how it should work. And then they talk themselves out of building it because they think they're not the right kind of expert. So I want to make the case that they might be exactly the right kind of expert to solve those problems. That's the thread I'd like to sort of explore along with everything today. And I guess the easiest part to start may be, my electrical background and how I got into IoT Studio.
So yeah, that's what my next question is. Like, how was your 7 years of experience in electrical background, and what is your motivation to start your IoT, own
Uh,
IoT?
yeah. So, like I mentioned, I've been a master electrician for more than a decade. I've run the contracting company. And in that time, I've worked across the residential, the commercial, and building automation. And I want to be specific about the building automation part because that's actually where the whole conversation starts. So, building automation, most people don't know this, but it's essentially IoT or the Internet of Things in an older, more professional form, right? It's sensors, controllers, set points, and logic, all coordinating to run a building. The protocols are different. You're talking BACnet and Modbus instead of MQTT and Wi-Fi, but the architecture is exactly the same category of thing, right? A temperature sensor reads a value. A controller evaluates a rule. You have valves open, you have dampers closed, you have fans that change speeds, right? So sensors, logic, and outputs. It's the same mental model as a smart thermostat in your house. It's just scaled up to a commercial building and running on decades of industry standards. And here's the thing you learn when you're installing hundreds of these systems across dozens of manufacturers in every kind of building. The logic is the same across all of them. The underlying patterns are consistent, right? A sensor sends a signal, a controller evaluates a rule, an output fires. That's it. So what actually differs between the vendors isn't logic. It's where each vendor's lock-in boundary falls. Which three-quarters of the job you get to do before you hit the wall that they built. So there's a couple walls that people will run into. A couple of them are the programming wall. So we can wire sensors, we can put in controllers, we can pull cable, we can terminate everything, and we can commission the network. But to actually write the control logic, you need the vendor's proprietary tool, and it requires a dealer license, a dongle, training certificate, or all three, right? The mechanical and electrical work is a portable skill, but the last part isn't, right? You hit a graphics wall, right? Your sequence of operations is running, trending is logged, alarms are all configured. But the moment the customer wants something custom, a custom floor plan graphic or a dashboard that pulls two systems together, You're either buying the vendor's graphic package, you're hiring a certified integrator, or you're exporting to a third party and paying per point licensing, right? The data exists. The wall is between the data and seeing it. So you have these other walls. You have an integration wall, right? BACnet. It says everything talks, but in practice, you can read the points, but the writable points are locked. Proprietary array access is restricted, right? Or the open protocol gateway is a $3,000 license. So you did 90% of the integration with a screwdriver and a laptop, but the last 10% is a PO to the manufacturer, right? So, right, you see all these patterns play out for long enough, and you start realizing something. It's not that the engineering is bad. The engineering is usually perfectly fine. The problem is that every one of these systems is designed to capture you, right? They're closed systems. They're expensive subscription models, proprietary protocols. The business model is lock-in. And the thing about lock-in as a strategy is that no single vendor can possibly anticipate everything a real customer needs. And so what you end up with is this incomplete products. Customers are always choosing between partial solutions. They pick the closed system that does the most of what they want, and they live with not being able to do the rest. So as an installer, that means I can only deliver 3/4 of what my customer is actually asking for because the vendor I'm locked into draws the line there. So bringing this back to IoT, homeowners are feeling this too. So your viewers might be aware of Matter the protocol. So the big players, Apple, Google, Amazon, and Samsung, obviously, had to do something about their customers screaming probably about all these incompatible ecosystems, right? Nobody wants 5 different apps for 5 different devices, right? So they built Matter as a device layer protocol, and that's generally useful, but Matter is a device layer fix. Homeowners are still choosing someone's hub, someone's app, someone's cloud. So Matter is an improvement, but it's not a full resolution. And that's why in the space, the honest solutions are open source, right? You have Home Assistant is the big one. Millions of people are running it, right? Massive community. It's a generally very impressive project. I use it. IoT Studio integrates with it. And the reason it exists at all is that enough homeowners and installers like myself, they got tired of delivering 3/4 of a service and decided to just build the complete version themselves. And so that's where I was a couple years ago, master electrician, right? Running a contracting business, watching the same patterns repeat on every job, closed systems, incomplete solutions, customers who deserved better, right? And I'd come home and I'd think about how this should work. Because after 10 years of installing these things, I had a clear picture in my head of what it should feel like, right? What an installer should be able to do, what a homeowner should be able to design. So the problem wasn't that I didn't know what was missing. The problem was that the person who builds it and the person who could see it weren't the same person, right? So I sat down and I decided to become both. So I taught myself to code. And not because I wanted to necessarily be a developer, but I wanted to build the thing that should have existed, right? And that's a difference. A developer learns to code because they love the craft of programming. I learned to code because it was the only path to the platform I could already see in my head. It was the bridge. And so after a year in, we have IoT Studio, not the idea, we have a working platform. And the thing I'd been picturing on job sites for years is now actually running and letting people build what I knew they wanted to build. So, do you have, did you want me to take you through IoT Studio, or was there
Yeah,
something about my
yeah, yeah,
journey that you wanted to dig into?
yeah. Showing that, makes more sense.
Yeah, yeah. Okay, so IoT Studio is in a one or two sentence here. It's a visual platform that lets anyone build real smart home devices and systems from their browser. Okay, no code, no libraries, no firmware research. You think in terms of what you want something to do, and the platform lets you do it. The way I like to frame it is like this. Most people have a vague sense that their house could be smarter, right? You've seen the products, they've bought a couple, maybe they have a smart bulb or a video doorbell, but they've never sat down and actually designed a piece of their home's behavior. IoT Studio is the first tool that makes that sit down possible for someone who doesn't write code. So if I can walk you through what it actually feels like to use. So say you want to build a leak detector, right? You have a dishwasher, you have a washing machine, or a water heater, right? Something where water can go wrong, right? So most people will go to Amazon, they buy the Wi-Fi leak sensor for 50 bucks, right? They plug it in and hope the app manufacturer still exists in 3 years, okay? In IoT Studio, you open your browser, you've got an ESP32 on your desk, it's a $12 board, right? The first time you use it, you flash it, okay? That takes under a minute, and it's a one-time thing. After that, the board talks to the canvas. So you're on your workspace, you're on a canvas. You drag a water sensor component onto it. You drag a notification component onto it, right? Let's say you wanted to send a buzzer sound. Let's say you wanted to send an email to yourself, an SMS text, a ping to a Discord channel. That's just a notification, right? You drag a line between them both. That's the logic. Water sensor fires, notification goes out. You click deploy, and in seconds, the device on your desk is now running that logic. So you can quickly wire it up. It's 3 or 4 wires. Touch the sensor leads with a wet finger. Your tone plays. Your phone buzzes. You just built a working leak detector. 5 minutes, start to finish. And most of the 5 minutes was you deciding where you wanted the notification to go, right? It's as simple as that. You put that device in a little enclosure, stick it under your dishwasher, and you're done, right? And here's the part that makes it, I guess, that makes it different from buying that Amazon sensor. The same canvas will let you build 30 more things the same way. A garage motion light, right? That only triggers after sunset. A sump pump current monitor that tells you if the pump failed during a storm. A workshop dust extractor is a big one that our customers use, right? That kicks on the moment a table saw draws current and runs for whatever time or delay you want it after you stop cutting. Now, some of these you can actually buy, right? There's a plug-in device you can get that'll trigger a dust extractor when you turn saws on, 50 bucks or more, but the timing is hard-coded, right? You get whatever delay the manufacturer picked. It doesn't talk to anything else you own. And if you decide later you want the shop lights, let's say, to come on, when the saw runs, or the compressor to shut down when the saw's been idle for 20 minutes, or any of the other things a real workshop might want, right? You're out of luck with the current technology. You've bought 3/4 solution at full price. So it's the same pattern we talked about earlier, but now it's at the device level for homeowners. So in IoT Studio, that sensor is just a signal. And that signal can drive anything else you've built. The effort to build the second device is less than the first. The effort to build the 10th is almost nothing, right? Because now you understand the interface and you understand the timing and the combination, right? And so you tend to get better and better as you use the program because you're the one who's designing the logic. Okay, so the whole platform is really 4 moves, and I want to name them because I spend a lot of time on vocabulary and choosing the right terminology for things because it's an easier picture in people's minds, right? So the first is watch. Every signal, every sensor value, every event, it's all live on a timeline. You can see your system thinking. When a button gets pressed, when a temperature reading comes in, right? When a component broadcasts, it all shows up on screen the moment it happens. And that's a huge deal for a non-developer because it means you don't need to guess what's going on. You don't need to read logs. You watch. right? So the second is build, and that's the canvas. You drag components, you draw your connections, and you shape the behavior visually. If it's on the canvas and it's working, it's going to work on your devices. There's no separate step where you're compiling and wiring up through a config file. What you see is what's running. Okay. The third part is tune. And this is the part that makes the system intuitive. Okay. Every component broadcasts. Every component can tune in and listen to a broadcast. So you decide what listens to what. A water sensor broadcasts that it's wet. A notifier listens for that broadcast and fires. A rain sensor broadcasts that it's raining. A sump pump monitor broadcasts that its pump isn't drawing current. If you tune a notifier to listen for both of those signals, well, you've just composed a sump pump failure detector. You didn't buy it. You didn't find it in a catalog. You composed it. Okay? And the fourth is deploy. You flash your board once, under a minute, one time. From then on, every project you build deploys on that device over the air in seconds. You're not plugging that back in to a USB cord to your computer. Everything is over the air. Okay? You don't have to touch that hardware again. It lives in the wall. It can live at the cottage. It can be out in the field, wherever you put it, right? You change your mind, you deploy, and it updates. Very simple. So I guess I want to sit with that sump pump example for a second, because I think it really captures what's actually different about my platform compared to some of the other ones, right? You can't really buy a smart pump failure notification system. The product doesn't really exist. What exists is a sump pump and maybe a water level alarm that you can bolt onto it, right? It will trigger if their alarm level high, but it's a bolt-on system. Nobody sells a version of a sump pump that notices it's a storm outside, checks the pump is drawing current, and then fires your specific notification that you want, right? That product would have to know about the rain. It has to know about current. It has to know about your house and about your preference. No manufacturer is going to build that specific combination for you, but you will, right? Because every sensor you put in your house broadcasts a signal that the rest of your house can listen to. And every project you build becomes a signal that adds on to every other project, right? They can compose against that signal. So project 1 is one device. Project 12 is a design decision. Project 47 is something you thought of, and you're making connection between two different signals, right? And you have it running by lunch. So here's the thing that IoT Studio gives you that nothing else in the space does. We handle the firmware, we handle the deployment, the OTA pipeline, the device management, and the protocol work. None of that is your problem. You spend time in the creator phase, deciding what you want, shaping the behavior, composing projects. That's IoT Studio.
So what all the devices that can be able to connect to this?
So right now we've set it up so we build our own devices. You can build your own devices using ESP32. Any of the like the ESP32 S3 dev board is an incredible board. So I've initially pushed out for the ESP32 S3 to be the board that we support right off the get-go. It's a very inexpensive board, and that's where we're going to start. I am eyeing Arduino compatibility, Raspberry Pi for hubs and stuff, but we're starting nice and simple with a device that is proven. As of now, we can connect to any of the integrations, webhooks, MQTT. I send notifications to Discord using our systems. So we get pings, we can send emails. We can integrate with almost any other product these days because of all the different APIs that everyone's providing. We're able to bring them into our system and use any signal basically from any of your other systems, whether it's an email you get, any integration avenue, even home automation. You can send signals from your home, your home assistant.io system, and send signals into our system, run the logic, and you can send it back to the IoT devices that are already running on your home automation system. I did talk a little bit about the Matter protocol, and that's something I'm keeping very much aware of. I think that's going to be a huge component, is to see how these devices, if we can integrate them efficiently into our system, how you can create your own Matter devices. So there's a lot of very interesting things coming in the horizon now that we're moving to more of a unified way of these IoT devices interacting with each other. So yeah, like I said, that's essentially what we're looking to do as far as integrating with other things. But if we zoom out a minute, I can talk about something, I guess, a little bit about bigger than IoT Studio, and it's the history of code and how this all sort of fits in, if you're interested in that.
Yeah, go on.
Okay. So the history of code. We started with punch cards, right? Physical cards with holes in them. And you'd punch a pattern of holes into the card, and you'd feed that card into a machine, and the pattern would tell the computer what to do. Now, why did we do it that way? Because we needed a way for humans to instruct a computer. And that was the best anyone had. Literal physical cards, punched by hand, fed into a room-sized machine. Does anyone use punch cards today? No. We moved on. Why? Because it was too much friction for the work that we were trying to do, right? So we moved to assembly. Slightly easier than to high-level languages, Fortran, C, a whole family of languages that grew out of that. And here's a question most people don't stop to ask. Why are there so many programming languages? Like, why Fortran and C and Python and JavaScript and 50 others, right? The answer is that each one was built to remove friction for a specific kind of work. Fortran for scientific computing, right? C for systems programming. Python for rapid development. JavaScript because we needed something to run in browsers. Every language exists because someone looked at the layer below and said, well, for this kind of work, this is too hard. There's a better way to say what I mean, right? And that's the whole arc of the field. Every abstraction we use today exists because a human looked at how we were instructing machines and decided the current way had too much friction. Compilers exist because writing assembly is too much friction. Frameworks exist because writing raw language features is too much friction, right? Libraries exist because reinventing common patterns is too much friction, right? It's the same move over and over across decades. Remove the friction and you keep the compatibility. Pardon me. So now look at what's happening across the broader industry right now, right? We're seeing that same pattern happening in parallel across every creative field, right? Figma has replaced hard-coded CSS layouts for designers, right? Designers used to have to either code their layouts or hand them off to a developer who would code them. Figma removed that. Webflow did the same for a whole website. Airtable replaced spreadsheets and macro business automation. Zapier, they let non-developers wire together systems that used to require a full integration project, right? Each one did the same thing. They removed the code and kept the capability. You put the tool in the hands of the person who actually had the design in their head. And so IoT Studio is the same move for hardware. For people who want to design a smart device and deploy it and have it work without spending 3 nights at 2 a.m. trying to get firmware to compile, right? Without researching what breakout boards work with what library, without learning the whole ESP32 toolchain, right? Because honestly, very few people love that part. It's what we have to do, but not what we want to do. So people generally, like some people generally do enjoy the challenge of firmware work, and that's great. They'll keep using tools that they love, and those tools will keep getting better. But most people want an outcome, not to fight with that tool chain. Okay? And so that's the beauty of is we handle the firmware. We handle the deployment. You spend your time in the creator phase. In IoT Studio, that's all the time. So the whole trade-off is we take the tedious layer and you get that creative layer back, right? Which brings me, I guess, to something else that kind of comes into it is, I guess, the solo founder journey is another one that we can touch on. But do you have anything else that you'd like to ask about that, or?
Sure. Can you show the user interface?
You mean live?
Yeah.
Let's see if I can. I'm not familiar. I don't know if I can put it up on this webcam. Um, Let me see.
You can share the screen.
Okay, if you just 1 second here, and you'll have to pardon me just for a moment here. Let's see. Let me pull the actual screen apart here, and we'll go here, and we'll do this. Okay, so let's see if we can share my screen. Camera, share content. Okay. So let me know if you can see that screen there.
Yeah, I can see you.
Okay, so you can see the interface now?
Yeah.
Okay, so that's essentially the IoT Studio. Okay, and I designed it so we have our whole component palette on the side. It's a simple drag and drop interface. In this case, you can start seeing the timeline, right? The timeline shows you right away your button's released. In this case, I'll show you a quick little setup. So when your button's pressed, we're going to turn the LED on. When the button's released, we're going to turn the LED off, and we connect. It's as simple as that. What happens is, let's say we want to do anything we want from that. We have comparators. We can pull in signals from other solutions. So here's a water and plumbing sort of system. And I've been designing these mini projects so people can build these projects very efficiently and quickly, right? Here's a leak alert. We have a leak detection with auto shutoff. We have a simple sump pump alarm with a current transformer. And all these, as you can see, you're pulling components and you're assembling them logically, right? In this case, if we go to the top, we have a leak sensor. And this leak sensor right now is a simulator. But we can choose an actual water sensor module from real breakout boards from Adafruit or someone else. And while we're designing this, we can simulate And we can test our logic right here. I've tested the leak. Our timer's going off for 10 seconds. We want to make sure the leak's there for 10 seconds. Once the leak has set off, we now have in our video displays, we still have video. So I'll just zoom in here quickly. I have a quick little detected. Okay. So it shows detected in the top. What happens is when it's been cleared, it's cleared right away. So I've also incorporated the whole visual side of this. You can add OLED screens. You can add e-ink screens. It doesn't matter. You're not dealing with that. You're choosing what OLED screen you'd like. So you can come into the configurations. You're choosing here. There's a couple 4 pins and I have a 7 pin that I use all the time. You're choosing the display you want to use that you have at home. And in your screen, everything's running exactly how you want it to run. When I deploy, which is right here, I'll deploy. I'll choose one of the breakout boards that I have. I just choose one of the groups that I have. In this case, let's say a water sensor. I'll show you. So the groups that we have here, we have devices at the top that we've brought into our system, and we have groups that we've created of components. So if I go back here, you can see over here, we have group names. So leak alert, leak detection, auto valve shut off. If we're deploying, there's my leak alert. There's my leak detection and auto shut off. And if I click them, there's the button that is within the group. There's my leak sensor that's within the group. From this component, I can choose the real piece of hardware that I want to use on my device. I can choose the pins, right? I can choose a double tap window if I want to use the button as a double tap. And it's as simple as this. I click leak, I hit deploy, and it's deployed. That's it. That's it. You're not messing with firmware. You're not coding. That's the extent of the system. Okay. And if I can do a quick, if I can quickly unshare the screen, I'll just quickly unshare that content for a second so you can see me again. I'll show you a quick demonstration. So I mean, I'm not sure how well that turned outside, but it looks like it was pretty fuzzy on that. But essentially, that's how quick the components, the system talks to each other. I have 4 ESP32s all running on the same types of groups, all interrelated. I have one ESP right now that has a light sensor and a motion sensor. And then I have another ESP that runs a relay that will turn on and off. I have the other ESP running my signal lights, and then the other ESP is running my display. So I can have those ESPs running all over the house in different configurations. No one is having to deal with cross device talk. They don't have to deal with firmware, right? They don't have to deal with flashing and reflashing. The deployment is in seconds over the air, as you saw right there. And so that whole interface, that drag and drop, it allows those that enjoy, I guess, the whole node-based systems, but allows them to really craft what they want to see out of a bunch of devices, right? So that's the really that's been the really interesting thing, is kind of watching that whole part kind of come into it. So yeah.
So what was the cost of it?
The cost, I've written this right down. The cost is, I believe, yearly it's $12. Sorry, monthly it's $12 a month Canadian. Yearly it's $10 a month Canadian. And that right now, that's essentially, basically, essentially covers a lot of the fees for egress and the CPU costs and stuff like that. I've tried to make the whole system very affordable. Um, the idea is to really allow people to see what it's like to have the intent, human intent, design the system, right? Um, if it's one thing that I think that people get away from is this idea that there's a one button that sort of fixes everything, or there'll be a time when people, you can type into a website and say, design me a website. That day is never going to happen. The human intent always needs to be in the loop. So if you want, I can try to demystify AI a little bit, because I know your viewers, right? Everyone's talking AI, right? And I just want to demystify it a little bit, if you wouldn't mind, because the conversation around AI, it gets confused a little bit. And so what I'm trying to say plainly is that AI, in the way we're using it, is a pattern matcher. That's what it is. That's the mechanism, right? These systems are trained on enormous amounts of data. They learn statistical correlations between patterns in the data. And when you give them a prompt, they match that prompt against what's already learned, and they produce the most likely continuation. That's the technology, stripped of the branding. But here's the thing most people don't realize. Computers have been pattern matching at high speed for decades, right? Credit card fraud, that's pattern matching. Spam filters, pattern matching. Search engines, right? Pattern matching. Medical imaging analysis, recommendation systems, language translations, like all of that is pattern matching. So what's new isn't the capability. The capability's been there, but what's new is the target, right? We pointed that pattern matching at language, and we've done it at a scale that feels qualitatively different. But it's not qualitatively different. It's the same thing. It's faster, it's on more data, in a domain that happens to feel personal because language feels personal, but we're not witnessing magic, right? We're witnessing a very old capability pointed at a new target, right? So let's talk about some of these companies. Anthropic, OpenAI, Google, there's Canadian labs, right? I want to be clear, like, these are great companies doing genuinely incredible work, right? I use their tools every day, right? My respect for what they built is real. So what I'm about to say isn't a critique of them. It's just an honest description of the business. But what these companies are actually doing underneath the branding and the conversational interfaces is they're selling compute time for pattern matching against enormous correlation data sets that they built. Like, that's the honest description, right? You type a question, their server runs your query against their trained models, right? And they charge for the compute that it took. And they hand you back the most statistically likely continuation. That's the business. So the sensation of that, the speed, the fluency, the fact that you can have a conversation that feels real, like, that's what's shocking everybody, right? It used to shock me, right? But the mechanism under the hood is pattern matching. It's fast, it's at scale, and it's against correlations. So that's not a diminishment, but that's pulling off that consumer grade reliability, right? At the speed that it happens. And to be able to do that is a tremendous engineering achievement, right? It's just not magic, right? So if I'm being honest about my own relationship with these tools, because, like, I don't want to sound like I'm lecturing from some anti-AI high ground. Like, I'm not. My software, IoT Studio, like I can't build that without AI. Claude, Chat GPT, the whole stack is part of my loop every single day, right? I use these tools for code generation, for documentation, for system design, for the reviews, for editing copy, right? I'm not going to stand and say, like, I pretend I could have shipped it without it. That's not true. These tools are allowing things to happen that couldn't have been done before, right? A solo founder with traditional tools from 5 years ago, they'd be working at a real disadvantage. They could not do what I'm doing. So I'm not an anti-AI founder. I'm the opposite. I use this stuff as a genuine force multiplier, right? It lets me move through that organization and that pattern matching work that would otherwise take me weeks or months, right? A year of work by a solo founder today with good AI tooling is probably equivalent to 4 or 5 years of work by the same founder without it. That's how big that multiplier is, right? But again, like I said, I want people to understand that there's not going to be this day when you pull up a screen and you type a sentence and it's all done, right? Or a finished smart home. It doesn't matter how good the pattern matcher gets. That day isn't coming, right? And I want to be specific about why, because the reason matters. Building something real, something that works, something people use, something that lasts, that takes a year or more of dedicated hard work, putting your intent behind those decisions. Every tweak, every trade-off, every moment where two things could be true, but you have to pick one, right? A pattern matcher can help you explore those options faster, but it can't help you see what those similar solutions look like and where they're going to go. It can help you draft, it can help you revise, but it can't supply that intent. And the intent is the thing that says this and not that, right? And every product that's ever been built at a level of quality that makes it worth using has been built by tens of thousands of those small decisions, right? This, not that, right? No one can replace human intent. And that's what we're actually talking about when we say human in the loop. Not human approves what the AI does. That framing is pretty shallow, right? The real meaning is that the human supplies the intent the AI pattern matches against. Without human intent, the pattern matcher has no patterns to follow. And that's the whole argument, right? Compressed. It's why founders who take the human in the loop part seriously, I believe, are going to outbuild the ones who don't. Because they understand what the tool actually is and what AI isn't, right? So that's the frame on pattern matching that I think is very important.
So, what do you say about your system to my audience? Anybody who is watching this from anywhere in this world?
About my system?
Yeah, the system that you have created, the problem that you have solved.
Well, the problem we've solved really is that gap between the end user and those that are designing software. And it's not that there's not a need for developers. Like, there's so many different computer languages now. There's still people coding in all the different language. Just because a new language comes out doesn't mean people stop using C or stop JavaScript or these other coding languages. All IoT Studio does is allow more people at the layer of the design work. So a lot of people would be hesitant to design their own smart home devices, to look at their home and look at the signals. And some of that, if you're having to code, is very tricky to get into. It's very daunting and it can be intimidating, even for myself who's in electrical and who does this. But IoT Studio bridges that gap. It allows anyone to have a look at those systems, at the components that build these systems. And whether you use it for yourself, whether you're a professional, whether you're a student, a teacher, an educator, the system is designed to adapt to all of them because it works at the level of logic and thinking, not at code, which was always meant to be the language to get a computer to do what you wanted to do. Well, once code is not involved in getting that computer to do what you want it to do, because the system design is designed properly, you don't need code. Not all the time, right? Obviously, if somebody wants to develop further, like those avenues don't disappear. You're still going to develop your own projects or products, and you might want to build your own firmware. You might want to delve into supporting different components and devices, but IoT Studio is just going to open up that door to so many more people to system thinking and looking at their home and saying, what are the signals that I can pull out of this, right? In Canada, there's a lot of basements and they flood all the time. And one thing Canadians forget is that when they walk into their dry basement, the basement's actually giving them a signal. It's saying, I'm dry, I'm dry. It's not till after the flood and the water has ruined their family photos and it's ruined their furnace and their equipment that now they suddenly say, oh, I should have been aware of the signal my basement was giving me when it went from dry to wet. Not a lot of people have that device sitting there ready for that point in time. And that's what I'd like to get across a little bit about IoT Studio, right? It really is allowing you to pull those signals from where you see they are in your life, whether it's at home, whether it's at work, whether it's in the field. I mean, you can go down to your local stream, your local ponds, and using different sensors, acquire data that you feel is important to improve your world and your community. But you're designing it, right? You have access start to finish, and you don't need to be a coder to do it.
So I'll put the link, your product link in the description of this video, also on the screen as well. Can you spell it to my podcast listeners for listening this on audio?
Sure. IoT Studio .app is the website name. And from there, you can have access. You can see structuredlanguageintelligence.com. You can see our Kickstarter. And, I'll just talk a little bit about the Kickstarter. Our Kickstarter is live right now, and we've set a modest goal, and that's on purpose. This is a signal test. I'm not building a war chest to get going on everything. We're trying to find signal. We're trying to find, are there homeowners? Are there other businesses? Are there people that are looking and see the possibility of IoT Studio? Do they see that they can construct their own logic, that they can control their own way of reading the world and using that data for themselves, right? So that's the whole point of these reach outs, is to really see if there's a signal that's going to come back and say, yes, I see what you're doing. And so I'm just looking for as many people to, start the conversation. If you see something interesting, you get in touch. If you have a company that you feel that might be able to integrate, let's reach out. Let's see how we can keep bringing more and more people into the wonderful world of IoT, the Internet of Things, and being able to properly use, like I said, the signals that are around us in everyday life. Let's start using them for ourselves. Let's start seeing and building and allowing ourselves to be part of that next stage that we're hitting.
Great. I'll share those links also on my website as well. People who finds this conversation anywhere in the internet, it can be on social media or on my website or any social channels, can able to see uh, uh, this solution, and definitely they will reach out to you uh, 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 to discuss more.
Yeah, that's just it, right? It's just, if you'd like to have a conversation, understand more, I'm very open um, to kind of discussing this. I think I'm a big proponent of the human in the loop, and like I said, it's not the human approves the AI. I really believe the human's intent is what's going to guide this next stage of development of this software world that we're moving into, right? The opportunities are everywhere. There's broken systems everywhere. We see it in our education systems. We see it in our financial systems. We see it almost everywhere. We There's so much opportunity right now to look around us and say, you know what? These systems were broken, and not from malice or or intentionality. The technologies are changing. The ideas are changing. What's possible is changing. And so we must have the conviction to go back and look at some of these broken systems and just say, hey, there's a better way, right? There's a better way to put this together. And the consumer, the customer, the end user deserves more, I believe, in a lot of cases. So.
Great, great. At last, as an inventor, as an electrician, as a coder, as a problem solver, what's your observation about my work? Have you seen any videos of mine on YouTube?
You know what, man? I dug into your videos, and um, it was very inspirational. You have just such a wonderful line of guests there. I mean, I got caught just kind of listening through all the different speakers. They were exceptional, right? Just I really love what you're doing. Just establishing, getting these conversations, right? There was I think his last name was, I forgot what was his name. He was they were talking about physical AI. It was a recent one, and it's just so fascinating seeing the same passion from a lot of these entrepreneurs, right? You can see the passion, you can see them trying to think outside the box. Everyone's seeing the same thing. There's better ways. There's better ways. And and I love that the tools are there to do it, right? Like a solar founder like myself, like I don't have to worry about database management necessarily. I mean, you can, right? You got Supabase there, or you got Vercel for your front end, or you got Railway, or you got a whole host of these wonderful scalable architectures, which allow us to not have to sink so much into the infrastructure at the time of development, and it can scale appropriately with what we're doing. But so I love what you're doing. I love the conversations. Um, it's such an exciting time, I feel, and the opportunities are everywhere. And it's just wonderful to join in and be a part of some of all of this, right? So
So, I have done masters in software engineering, also bachelor's in computer science and engineering. Right now, I'm working as a DevOps engineer for a London company. Apart
nice.
from that, I'm interviewing experts like you who are working in different technologies and trying to solve problems and uh, trying to come up with the solutions, understanding the real time scenarios or the practicality. So. Uh, Apart from my original job, I'm doing these discussions and trying to explore what all being invented and how it is actually useful for the humanity. So I interviewed the world leaders, Amazon vice president, Salesforce vice president, and number of company chief executive officers who are working on different products and services from different countries. So as a person who is into technology and understanding technology, and uh, now you built a IoT tool. So how this conversations and this experience is going to add value to my personal career,
Sorry, is going to add value to what?
to my personal development or personal career or for my future? How it is going to helpful for me, these conversations?
with IoT Studio specifically.
With everyone who are doing, with everyone that I'm interviewing, how
Oh,
these
like
experiences,
oh,
conversations are going to helpful for me,
oh, how are these experiences going to help?
me in future.
Oh, for you in the future.
Yeah,
Oh well, I think a lot of a lot of I guess learning is about understanding the depth of the information. And as you're trying to find out, I guess, what is the way that you see uniquely, um, you need to go through a couple stages, right? You need to go through and understand and read everything, see what's all out there. Um, but I think people have to trust themselves that you know you better than anyone else in the world. You have a unique look on life that no one else in the world has. They could be in the same town, the same place, the same street. It's not you. So I feel the true development's going to happen when people start tuning in to what their life experiences make them unique, and they start adding that into these systems that we have, because everyone has such a unique way, and usually a great way, from their experiences of whatever they're passionate about. And so if people just follow that passion, and they follow and trust the fact that their experiences are leading somewhere, and they can tune themselves into that, I think like yourself, you you grab as much information as you can, and you'll find what way makes the most sense for you to affect change in this world. I mean, I've only found that out in the last 2 years. I've been an electrician. I've helped people in job, in their homes, and safety and all that stuff. But I know my life work is where I'm headed now, educating, right? Bringing more people into passions that I have, like IoT Studio, opening up doors for other people so they don't have to walk through the same steps, those same doors that were closed for me or difficult. That's something I find so enjoyable, and I think that's a common thread from a lot of your guests. They're really looking on how they can be part of the betterment of society, whether they're helping other companies or whether they're trying to find solutions to this. They're just pushing and pushing to find their own unique way of being able to make real difference in this world. Right?
great observation.
Yeah,
Thank you again. Can I put this conversation on my podcast with your permission?
for sure, for sure, for sure.
So I hope it reaches to maximum people, and I believe that your work will be helpful for a lot of human beings.
I hope so too, and that's the goal, right? I think that's, if we can get more people to just be a part of it. They can always learn to code later, they cannot, but I think the more people that are included, the more we're going to find the proper solutions to our broken systems. And we got to move quick. We have some broken systems, right? Whether it's water pollution or air pollution, there's so many things that you can tackle. And that's the exciting part, is we have a world of opportunity ahead of us, and we have a lot of wonderful technologies that people are creating. It's just a matter of connecting those dots and giving 100% of what you can. Right?
Sure, sure. Thank you, Brett, again for your valuable time and sharing your experiences and telling us what you have built and how it is going to be really useful for humans and what all they can do. And it is so inspiring your stories.
Uh, I appreciate that. Thank you very much for having me. And I hope the conversation has been useful to your audience.
Definitely.
And again, I really appreciate you reaching out and making this possible.
Thank you, sir. Take care.
Take care, Si.